Our conditional probability formula, which is written with division, can also be written with just multiplication. So recall we said that the probability of A given B is the probability of AB over probability of B. Similarly, the probability of B given A is the probability of AB over probability of A. Now if we multiply both sides by this denominator, then this gives us two expressions for the probability of A and B. Probability of A and B equals probability of B times the probability of A given B. It also equals probability of A times the probability of B given A. And this multiplication rule holds for n different events, not just two. So that is the probability of A1 and A2 and A3 up to AN equals probability of A1, times the probability of A2 given A1, times the probability of A3 given A1 and A2, times the probability of AN given A1 through AN minus 1. And it's sort of easy to see why this is true. The reason is that the right-hand side is probability of A1 times, this is probability of A1 and A2 divided by probability of A1. Then this is probability of A1, A2, and A3 divided by probability of A1 and A2. And we can continue on, and then eventually we have probability of A1 through AN given probability of A1 through AN minus 1. And then if we look at these fractions, probability of A1 cancels, probability of A1 and A2 cancels, probability of A1, A2, A3 cancels with the next fraction, and then this cancels, and all we're left with is probability of A1 through AN, which is exactly what we have on the left-hand side. So let's do one example using the multiplication rule. Alright, so let's say we have an urn that contains 8 red marbles weighing R each, and 4 white marbles weighing W each. So let's say we choose marbles one at a time. And the probability of choosing any given marble is weight of that marble over weight of all the marbles that are in the urn at that time. I'm not sure this is a realistic model of how we would choose marbles if they were weighted, but let's just assume that it works like this. Alright, so the problem is, what's the probability that we choose red, red, and white in that order? So let's let xi be the color of the ith marble chosen. Then we want the probability that x1 is red, x2 is red, and x3 is white. So this is, by our formula, the probability that x1 is red times the probability that x2 is red given that x1 is red times the probability that x3 is white given that x1 is red and x2 is red. Alright, let me leave the numbers of marbles here. Now every time we remove a marble, we're not only reducing the number of marbles, but we're changing the weight of the marbles that remain. So the probability that x1 is red is, let's say, so we've got 8 red marbles. And for each one, the probability of choosing it is r over the weight of everything that's in there, 8r plus 4w. And the probability that x2 is red, given that x1 is red, is, so I guess there's 7 red marbles left. Each one of them weighs r, but the total weight of marbles in there is not 8r plus 4w anymore. It's 7r plus 4w. And then the probability that the third marble is white, given that the first 2 are red, is there are 4 white marbles in there. Each one is chosen with probability w over, after we take out 2 red marbles, I guess we have 6 red marbles remaining and 4 white marbles remaining. So that means that the probability is the product of these. I'll write them as just 3 fractions. So 8r over 8r plus 4w times 7r over 7r plus 4w times 4w over 6r plus 4w. So here, even though the problem doesn't really ask for conditional probability, it asks for an intersection of 3 events. It's easiest to analyze them if we take them one at a time, and then we update our probabilities each time given what we know about what's left after we've made the last decision. The end.